I'm Jason Garber. Thanks all for being here. Really excited to be at Wicked Good RubyConf. Well, that's not working. We'll just do that. I work at PromptWorks in Philadelphia. Me and two co-founders, we all started using Ruby in 2005. Currently we have a nice little team. We practice test-driven development, test all the effing time. Thank you, Brian. And all the other things that make us buzzword compliant. It's a great place to work. We have a fantastic team. And if we're talking this weekend and we don't know what to talk about, just ask me about our pairing setup. It's awesome. I could talk for hours about that. The Ruby community is thriving in Philadelphia. I think we've doubled our Philly RB attendance within the last year. And we really love having speakers and guests come from other cities. So if you're ever in the Philadelphia area, you should look us up. We have a great view from the 45th floor where we have our meetups. My talk today is about parsing. But before we talk about parsing, we should talk about DSLs, which are domain-specific languages. They're the computer languages that are targeted to a particular problem domain rather than general-purpose computer languages that can be applied to any sort of software problem. People find DSLs valuable because a well-designed DSL is much easier to program in for that problem domain. It improves your productivity. Also can be easier to read, so someone new to the software can grasp what's going on with that problem domain much more quickly. In some cases, it even improves communication with domain experts. We could debate about that, I suppose, but that's one of the benefits. Maybe we should discuss that later. About a decade ago, a lot of people were programming in Java and C#, and they found themselves writing a lot of XML. Because even though its syntax was very noisy, it allowed them to define their own languages. They could talk in the language of the domain. They could build out these hierarchical structures of that domain that weren't as easy in their host languages. And then, of course, Rails came along and wowed us all with its fluent, dynamic Ruby code, and DHH declared the end of XML setups. And Rails, really was like programming in a specialized language. It was a DSL for making web frameworks. I mean, it's a framework, but it was a DSL in its own way. Maybe to the point that, at least a few years ago, I would ask someone, and they'd say that they're a Rails developer, and I would have to ask some questions to find out if they were really any good at Ruby, because sometimes they didn't necessarily go together. And we talk a lot about domain-specific languages in the Ruby community, in part because the Ruby language allows us to build them so easily, and so we have a lot of DSLs quite frequently. Let's see, it allows you to express a lot of things much more easily than you would if you just had the functions and primitives and so forth. If you ever tried to build a DSL in JavaScript, you can appreciate what Ruby provides for you in that area. So I want to have a little fun right now. I'm going to throw up a DSL, and I want you to tell me if you recognize it. Say what it is. So this should be an easy one. What is this? Right. And this one? RSpec. Yep. How about this one? Capybara. Yep. Everyone knows this one, right? Rake. This one? Sinatra. Right on. How about this one? Silence. Yeah, Parslet, the subject of this talk. Yeah, this is a Parslet DSL. Now, all these DSLs I just showed you, they're all internal DSLs, as Martin Fowler calls them. Some people also call them embedded DSLs. And they use Ruby itself to make programming in that domain easier and dry up repetition and all those good things. There's also external DSLs. And external DSLs have their own syntax, and they require a parser and to process them. And if you're around Linux a lot, there's all kinds of different external DSLs that various programs have their own configurations. Let's see which of these you recognize. What's this one? Nginx. Yeah. How about this one? Does this count? Regular expressions. This one's easy. SQL, yep. This one? Awk, yep, right. How about this one? Slim. I'm glad you all got that right. That's great. This one? Cucumber. This one? Is Puppet. Good. Here's another easy one. Markdown. TOML, yep. There's a clue right there. Here's one. I'm curious to see if anyone gets this one. Lily Pond. Maybe it's Lily Pond. I don't know. Lily Pond, I think. Yep. Last one. PostScript. Yep, I heard it. Okay, I lied. Last one. Is it CSS? SCSS, right. And this is a good example of being able to communicate with domain experts. I know a number of people who, they write HTML, they write CSS, maybe some SASS or SCSS, but they don't consider themselves programmers. They consider themselves design experts or UI experts, but they know how to write this kind of code. So are they programming? It's a domain-specific language. Can you imagine if we didn't have CSS? What would the world look like? So external DSLs are important. And the usual way you handle it is you have your grammar, and then you have to parse that grammar. Maybe you have a parser that then has to be compiled. And then you have to run that compiled parser and stick in some input and figure out if it worked. Tools like Antler, Yak, Rack are kind of the traditional ways that people would parse grammars. How many people are familiar with Textile? I know Markdown's more popular, but yeah, great. Textile is a shortcut to HTML. Has the same elements, but a little bit cleaner syntax if you're writing a very specific, it can't handle everything, but covers a lot of the bases. And it's easier to write than HTML, a little bit easier on the eyes. And for many years, I worked on Redcloth, which is the de facto textile parser for Ruby. Why the Lucky Stiff ported it from PHP Textile in 2004. And it started out very much just a lot of regular expressions, like hundreds of lines of G-subs. And it was a mess, and he knew it, and everyone knew it. It was less of a mess than in PHP. He added tests, he fixed bugs, but still it was prone to regressions, and from one version to the next, things would change, and it was really unreliable in that way. And really, regular expressions weren't designed for that kind of parsing that it was trying to do. This one G-sub, of course, ran over the entire input, along with all the other G-subs that were in the file. And that's terrible, so inefficient, right? Of course, there's the good old quote from Jamie Zawinski that we love to quote. So in 2007, Why the Lucky Stiff said, you know what, I'm sick of this being nauseating. I'm going to start over, and I'm going to write it in Regal. I think the previous year, Zed Shah had written Mongrel in Regal, so it was catching on. So this is what some Regal code looks like from the Redcloth parser. It has its own syntax. It gets parsed. It generates a finite state machine that kind of works like a parser and executes bits of code that are embedded in it. And Redcloth was, Super Redcloth, his rewrite, was then compiled into a C extension for Ruby. And it was like 40 times faster than the G-sub version, which was awesome. As Wise commits were trailing off, he was getting more interested in shoes and less in textile. I was needing to use it, and so I started picking it up and adding features and committing. And then there came a point when he just one day turned it over to me and said, OK, it's yours now. And so I kept working on it. I released it as Redcloth 4 and kept hacking on it for a few years, even after Y disappeared. The problem was, though it started off fairly clean for C code, and it was fast. It got increasingly hard to add features and fix bugs and not slow down the parsing. Regel, I felt like, wasn't handling the complexity I had to be throwing at it. Probably the case is I just didn't know what I was doing, but the generated parser is a lot of tables of numbers, these matrices that as it calculates its way through the states. So even if I really did know what I was doing, debugging this is really difficult, and it's a bit of a black box. And then the worst thing of all is because it's in Regel, I didn't have a lot of other contributors. Plenty of people filed bugs, but even though it was on GitHub since 2008, there's only been a handful of people who contributed anything, and very, very few people who saw a bug and then fixed it. It's just too much of a learning curve and too hard to get going. So what I really wanted to do was to eliminate the ext folder in here. I wanted it to be pure Ruby, so that no one would, I wouldn't have to wait for compilation as I'm developing. There wouldn't have to be cross-compilation for JRuby and for Windows. And I wanted something that people could contribute to. So I experimented with a variety of approaches. I thought about and played around a little bit with regular expressions again, but maybe a little smarter this time. Thought about just kind of a custom top-down parser. But I did spend most of that time working with Treetop, which you may be familiar with. Cucumber, when it first came out, used Treetop to parse the Gherkin syntax. And so it has its own DSL for the grammar, which gets parsed, and then it generates a Ruby parser. And I got quite a ways with rewriting Redcloth in Treetop. But I had a few problems. One, Treetop was, go back, it's a D, yeah. Treetop was a little slow, actually really slow. It generated objects for every single character and then every single group of characters. And so I made some patches and fixed that and contributed them back to master. But it still wasn't where it needed to be. Also, I had some edge cases that I just could not figure out how to handle. And I was really pushing it to its limits. So eventually I gave up on that. There was also Michael J.I. Jackson, about this time, did Citrus, which is pretty much the same, except instead of generating the parser, it just did it in memory. And when he released it, I had also been working on something very similar. But I didn't make any progress on it for a number of months. And then one evening, I was checking my email from a cyber cafe in Nicaragua, and across it came Parslet. Kasper Scheiss released Parslet, and one look, and I was hooked. It's an internal DSL within Ruby to construct a parser. So you just make a parser class that inherits from Parslet parser, and then you specify a rule and give it a block. And in that block, we're going to match, in this case, a digit one or more times. Easy enough. And then we have to declare for the parser what its root rule is, and then all the other rules will chain off of that. And then, don't have to compile or anything, obviously, we just instantiate the parser and parse the number, and we get back a string. So the things inside the rules are atoms. The string method creates a string atom, and so it's going to match the literal string that you give it. All these atoms are parsers in themselves, so you can just call parse on it, and it'll spit back the string. It's actually the string plus, it's a Parslet slice. So from your input string, it's saying, well, this is the slice of the input string that I got. So it has an offset as part of it, which becomes useful later, especially when you're debugging. Another atom is the match, which you just saw. Match is kind of like a regular expression, but it only matches one character. So you can use the character classes, you can use the POSIX, let's see. Well, there's the meta characters, and then the POSIX character classes that have the colons on inside the square brackets. And then the last atom just matches anything. one character of anything. Parslet defines methods for sequences and alternations. The double greater than is a sequence, so good has to follow wicked. And if any of that's not there, then the parse fails. Below it's the alternation, Ruby or Elixir. It first evaluates on the left, and if that fails, then it tries the thing on the right. And those are the only two operators, really. And the precedence is exactly what you would expect. The sequence binds tighter than the alternation. You can use parentheses, of course, to change that order of operations. And then atoms can be repeated. This is what makes it useful. The first one repeats foo one or more times. The second one repeats it. The first one is the default. It repeats it 0 or more times. So it might not be there. It might be there 100 times. The second one repeats it 1 or more times. The third one is 1 up to 3 times. This repeat 0 nil, that's the same as the default. It's 0 or more times. And then the last one is 0 or 1. But if it's 0, instead of returning an empty array, it returns nil. So that's very useful. Two more things, presence and absence. So if we're parsing and we want Java to be followed by scripts, but we don't want to consume scripts. So for this part, we just want to consume the Java, but we want to make sure that the script is there. We can kind of look ahead with present. It's just the opposite with absent. So if I'm matching some digits and I want to make sure that they don't start with a 0, that's when I use absent. So if you're making a DSL, a new one, let's say, a new external DSL, you first need to decide what your legal syntax should be for the grammar. And that's what we just did, is define the parsing grammar. And then the next thing you need to do, once it parses properly, is to extract the data from that so that it's useful to you. You need to annotate it to know what's important data. Thankfully, that's really easy. If I just parse a string, it gives me back the string, the slice. But if I put an as method on it and give it a name, it will then return a hash with the name I gave it as the key and the string as the value. Easy. If I'm repeating and then I capture, it captures it all as one string. If I capture and then I repeat, it's going to repeat the capture. And if I capture multiple things kind of at the same level, it's going to drop anything that I didn't want to capture. And when you're parsing DSLs, there's kind of a lot of things that are important to know the context, but aren't actually data you want to save. So they just go away. So let's kind of go over reading something so you can kind of put that all in context. This is to parse a table. And if you aren't familiar with text-style syntax, or at least in Redcloth, you can start with table and then some attributes like CSS class or ID and a dot. And then the table below, but that's optional. And then the table below is just delineated with vertical pipes. And that's the HTML that it generates. So we're going to parse a table. And it needs to start with table and then followed by some attributes and a dot and a new line. But all that is optional, the parentheses. And then that's followed by one or more table rows, which we're going to save as content. And then that must be followed by the block end. So a table row is the thing with the vertical pipes. That's got some attributes, maybe, and then some content, and then the end of the table row. So there are the attributes, again, with the maybe. Then the table row content, it's either a header or it's table data. There's our alternation. And we repeat that one or more times, because there's one or more cells in the table. And then we save that as content. And then to end the row, we have our final vertical pipe, followed by either a block end, which is a couple new lines, or the end of the file, or the new line, excuse me. And the new line would just put it to the next line. Note then down here in the table data, we've got a pipe, and then we're checking that the next character isn't a new line, because that would indicate the end of the row. And that's not what we want to match in table data. You can do all the Ruby things with Parslet because it's an internal DSL, so method extraction, class inheritance, composition, duck punching, whatever you want to do with it. here I'm kind of maybe making a convenience method to wrap an atom in parentheses, so that if I try to match 500 in parentheses, it'll work without having to write that out every time. It's just a method. And here I've got an HTML tag parser, and then I make another class that inherits from it that's only going to parse block HTML tags. And we do that by overriding the tag name rule, just like we would if we were inheriting from a class with just methods. And for the tag name, we want it to not have an inline tag name. And what is an inline tag name? It's an array of inline tags, that's the constant down here. And I'm mapping and reducing to get a nice long list of strings with vertical pipes in between them to do that alternation. Here's something cool. We can just use IRB. We can dive right into the HTML tag and use the open tag method directly. And we can introspect it, do all the usual method things with it. And we can parse directly, as I showed before. But what happens if we parse something that shouldn't parse, the end block quote tag against the open tag rule of the HTML tag class? It gives us a pretty nice error message. It says what it was trying to parse at the time and at what character in line it failed. We can go a step farther and dump out a failure tree for debugging purposes. So here, I'm trying to parse an image tag with the block HTML tag. Obviously, that's not going to work, but why? The block HTML tag is 4 options: open tag, close tag, self-closing tag, comment tag. And there are 4 branches in our tree of the failure over here. The bottom one, of course, comment tag. We would expect that one to fail. So we can kind of go through and figure out what should have passed and why didn't it, and follow the tree down. The first one didn't pass, and if we go all the way to the bottom of it, input should start with inline tag name. Oh, sure, OK. That makes sense. It's giving me a lot more visibility into what's going on inside the parser with these good error messages. It's great to get the REPL for free and be writing Ruby instead of Regel and looking in this, trying to peer into the black box. But there's something more important happening here. Everything is an object, and everything's just methods, messages being passed around, and objects are returned from methods. So there's a great implication for all this. And maybe someone can guess at what it is. What can I do with this because I have all these, this faculty with Ruby? It's big in the Ruby community. What do we love? Gems, well, yeah. The old one was a gem. But testing, yeah, testing is the big thing. So I can just really simply, I'm using RSpec here, I can try out, make sure that the parser does what it should. But then I can also make sure that individual rules within that parser do what they should and fail when they should. And when the test fails, it gives me a nice output. So the third step when we're making a parser to parse our own DSL is to figure out how you want to work with the data. So the captures give you back this deeply nested hash. Then what do you do with it? Parslet gives you transformations as a way to deal with these hashes. They're probably not my favorite part of Parslet, so I won't spend a lot of time on it, but it is a lot better than having to work with hashes yourself. In the transform class, you just create a class, and you can define a rule that matches a single layer of the hash. So here I'm just saying anything that has a key of an int, pass it off as x, and turn it into a Ruby integer. And then if I apply it, I still have my left now is a 1, and I still have my plus sign for the operation, and my right is an actual integer 2. Then if I add a rule for the left side and the right side, and I add them together, then when I apply it, I get the result 3. So it takes that parse tree, and it boils it down to whatever you want. I struggled with this initially because I thought that was my abstract syntax tree, and I was going to be able to transform it into my end result. But it didn't quite work that way because the way you sometimes have to parse things and capture things, the parse tree that you get back isn't exactly what you would want for an abstract syntax tree. So a lot of people build their own, and it's specific to their domain. So you might think, well, it's Ruby, and so it's going to be slow. And my answer to that is the usual. It's not that bad, and I don't care that much. I care a great deal about speed, but in my experience with it so far, it's not that slow. It's perfectly adequate, a lot better than Treetop. And there are ways to speed it up. So for example, in this, it's an ERB parser. There are two spots that are kind of bottlenecks for the whole parser. It's not just universally slow. There's some specific spots that could be optimized. And that's that line right there, and there's another one as well. It's trying to consume all the Ruby inside of the ERB tags. And so it's just chomping away until it gets to the end tag. And all of that is going to be the Ruby inside the ERB tag. But it's having to traverse over every character, first checking that it's not the end tag, and then consuming that character. Well, Parslet now gives us these accelerators so that you can take an accelerator and apply it to a tree and say, every time I see something, checking it for absence, and then followed by an any, and then I repeat that, replace it with some other more highly optimized way of gobbling up characters in this case. So it can be optimized, and sometimes you'll also just find that you're doing things inefficiently and can clean it up that way. Another way you can extend Parslet is with custom atoms. So you can create your atom, and really all it gets is a slice, and you just say whether it matches or not. Just return true or false in a way, which gives you some fun options. You can extend Parslet to do all sorts of interesting things. Let's say I needed to parse a limited set of natural language queries. Questions like, who makes the best cheesesteaks in Boston? Natural language is difficult, so I defer to engtagger, a corpus-trained probabilistic part of speech tagger. And we can create a custom atom that wraps that, and all it does then is check, is this a noun? Is this a verb? And it might look something like this. Maybe there's a question, and we're looking for various things, an interrogative, a verb phrase, a superlative, that sort of thing. And then at the bottom is where we just sort of go check, is this these kinds of verbs, or is it that kind of adjective? What else might you be able to do with Parslet? Well, maybe in your app you have the requirement that users need to supply formulas. You don't want to eval those in Ruby, or maybe they're more like Excel formulas or something, and you need to be able to handle that. Well, you could write a parser to handle that. Maybe you've got some log files, and there are lots of parts to it, and a regular expression would be a bad idea. You can pretty quickly write a parser that's very readable, and it's a date followed by an IP address followed by all these things. Maybe you can use I/O objects and parse things as they're being streamed in. Someone I saw online wrote a parser to parse these sorts of titles and divine all the different bits of the title and what that means. So when Ruby isn't quite fluent enough for you to write an internal DSL, sometimes you need to not be afraid to write your own grammar, to come up with your own external DSL. And Parslet makes it really easy. So maybe you could be the next Hampton Catlin or Jeremy Ashkenaz and come up with the thing that we've all been waiting for, or not. I don't know. So what can we take away? DSLs are amazing. They help you write better code and communicate domain rules. Internal DSLs are great because you can use Ruby to work with them, but sometimes you need an external DSL. And yeah, so internal DSLs are preferable if you can get away with it. Parsing is one of those areas that it seems like it's one of those dark corners that the light of automated testing and clean code and so forth has a hard time reaching. But I feel like with all the tools that we're used to using in Ruby to keep things clean and readable and not become a bloated mess can apply here if they're done right. So when you need to parse some complex data and you're tempted to reach for a regular expression, maybe you should have some situational awareness and think about, just consider whether there's another way. Now you've got a tool in your bag that hopefully you can use and pick up pretty quickly to be able to parse whatever comes your way. Thanks very much for listening. I hope you enjoyed it. I think we have a few minutes for questions, if you have any. Is that right? Yes, sir.
So regular is really fast because it produces state machines. So how much slower is Parslet compared to regular?
Okay. He asked how much slower is Parslet compared to Regel. And the problem is I don't know because the Parslet parser isn't done yet. And I feel like you can't really tell until it's done. I mean, I could run some tests, but the Regel parser didn't slow down until the last little bit where it was like, oh, it needs to handle unfinished quotations and becomes this big rule. And so I don't know. I would love someone to benchmark it and tell me. Yes, sir.
Is there any particular reason that you decided to go with something like Parslet instead of, for instance, doing your own recursive descent parser by hand?
Oh, yeah. Why did I go with Parslet instead of my own recursive descent parser? Well, one, I'm probably not that smart. And two, I feel like there's value in using something that other people can use and contribute to. I've been a poor maintainer of Redcloth because of time, and I wanted other people to be able to contribute. And if it's custom, you have to know a lot about it, and it takes time to dive in and get your head around it. I was hoping that with Parslet it would be pretty easy to fix things if someone had a bug. So that's the reason I went that way. Yeah. Who else has a question? Anyone else? All right. Well, thanks very much.